time out of your Sunday evening to check in. And everybody have a good nice week. Now available for demo.
Hello everyone and welcome back to Elmer Time. Today we're going to talk about Ohm's Law. We'll get you started a little bit on Ohm's Law, and if you're into any kind of radio hobby, you probably could use at least the basics of Ohm's Law. So, grab your calculator. If you don't have a calculator, pencil and paper. If you've got a cell phone, most of the cell phones nowadays do have a calculator built in. So, let's get started. This is Jeffrey, AD7LN. Welcome back to the radio room. Okay, so starting off, hello everyone. Topic today, Ohm's Law. I know it's math. I know it's not a favorite subject of most humans, including myself. However, it's good to know at least the basics with Ohm's Law if you're going to be in any kind of radio hobby, because it will be a benefit to know. So, getting out the calculators and all that, paper, pencils. So, who here? How about you, Miss Barky Dog? Tell me, what is Ohm's Law? What if I offered you a cookie? Okay, enough nonsense. Let's get started. Okay, starting off, Ohm's Law was named after a German physicist named George Ohm, and it's one of the most basic, most important laws of electrical circuits. And Ohm's Law states the voltage flowing across a conductor is directly proportional to the current flowing through it. So as you can see by this little cartoon here that you may have seen many times on the internet or in books, I tried to draw it as similar as I could. It was a poor drawing to begin with that I tried to copy. You can see here volts. This little guy is trying to push Mr. Amp through the conductor, the wire. Well, volts is the electromotive force. You see him kicking, pushing. It's the pressure of flowing electricity. Amp, or amps, would be the electrical current, a measurement of current, or the strength of the current being pushed through. And Mr. Ohm there, putting his rope around the wire here and tightening it up, making it harder for amp to flow through. Ohm is resistance. It's electrical resistance between 2 points of a conductor. So if you were to measure between those 2 points, you would say you had a volt ohm meter. You could measure the ohm value of how restrictive this point is for amp to be pushed through. So all of these, volt, ohm, and amp, have a relationship in electrical circuits, including one more that we'll get to a little bit later. But for the most part, Ohm's law you may see in books or online. Is this, I don't know, let me see if it's any better. Looks like I need a better marker here. Oh, that's much better. This is what you'll normally see in books. To make it easier for people to understand, I'm going to take E, which represents volts, and just put a V for volts. That'll make it easier to understand. So volts equals I, which is the current, or amps, and R is for the resistance, or ohms. So that's your most basic formula for the relationship between volts, amps, and ohms. And in my studies, there used to be something called the ohm circle, and it was like this. Or you could have an E here instead of a V. But just to make it easy, let's just go with the V. However, I found out later that most electronic technicians called it a triangle instead of a circle, but with the same formula. And the idea here is that in an electrical circuit, if you already know how many volts the circuit is running on, and you have a resistance measurement, and you're looking for the current or amps in the circuit, you would just take the voltage number and divide it by the resistance, and it would come up with your amperage. Or if you're looking for the resistance number and you have your voltage and amp reading already, but you're looking for the resistance, it's just voltage divided by amps. If you're looking for voltage and you already have the amps and the resistance numbers, you just multiply amperage times resistance, and that gives you your volts. Same applies for the triangle. Same thing, it just one's a circle, one's a triangle. Ohm's law is basically a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. There's a whole bunch of other relationships in different mathematical equations, which I'll show you here in a moment. But let's do some basic circuits for the math, just to show you what's going on. It's easy and it's kind of fun. Okay, here we go. Did all this prior to putting the camera back on, just to save a little time. So here's your basic electrical circuit. Here's a DC battery. This is the symbol for a direct current battery. Here's the symbol for a resistor. And it's just a simple positive to negative with the resistor in the line. Here's the amperage or current that we would use for the representation on that. So let's do a math problem here. Let's just say that this DC battery, here, let's try a different color here. Let's say this DC battery is 12 volts. Okay. Let's say the resistance value of this resistor, which could be a lamp, could be any kind of electrical device. Let's say it is 200 ohms. Excuse my ohm symbol there. Anyway, 200. And we want to know the current, or the amperage, of this circuit with these two numbers that we have available to us. So what do? We look at our triangle here for our formula, and we have the voltage and we have the resistance. So we have V and R, we don't have I. So how do we find this answer? V over R, so it's V divided by R. So 12 volts divided by 200. Get out our masterful old 1970s calculator here, and we would plug in 12 divided by 200 equals 0.06. So if you were to put an amp meter in line right here, it would come up as 0.06 amps. And that would be the answer. Pretty simple, huh? Let's say let's use the blue again. Let's say this was 20 volts. Okay. Let's say we already know the amps. 10 amps, 10 big amps. What is our resistance? What do? We look at the formula triangle again. We have voltage, we have amperage. V and I. We have the V and I. So again, 20 volts, 10 amps. We're looking for the resistance value. So what do? 20 divided by 10 equals 2. So R in this case would be 2 ohms. See, ohms are ohms. It's a measure of resistance. 2. What if we're looking for the voltage? We don't know what the voltage is of the battery, but we do have current. Let's say it's 5 amps. And the resistance is, let's say it's 200 ohms. That doesn't look like a 0, does it? There we go. So we got 200 ohm resistance, 5 amps for the current. We want to know what the voltage is. So we go over here to our ohms formula triangle. We have I and we have R. So what do? If it's next to each other this way, we just multiply I times R. So here we go, 5 times 200 equals 1,000. That means that this battery is 1,000 volts. That's a huge battery. Okay. And that's That's it. Now this doesn't have to be a resistor. This could be a light bulb, it could be a small motor, it could be, it could be any kind of little electrical device that's DC. And this equation still works the same. If it's some sort of device that's in this direct current fashion, your Ohms triangle will figure it out for your resistance, current, voltage. Now there's also another part of the equation that's also equal to voltage, current, resistance. It's part of a grand Ohm's law wheel. And let's get into that. Okay, so what if I told you there was another law? Let's make another triangle. And it's called Watt's law. Now, Watt's law is the power within a circuit that is the product of voltage and current. Electricity is measured in units of power called watts. And for those people that have generators on RVs or in household situations, you may register with the wattage thing. So, P is the representation for power, for watts. I, of course, is the current. E can also be changed over to V, if you like, make it a little easier, for voltage. So it's the same kind of calculation that the Ohm's law is. For instance, let's see, let's try blue. Let's say we've got a 12 volt battery, and our current, let's say it's 15 amps. Now we really don't have to solve for the resistance because we already have two of the three to make the equation work out, because we're looking for P. We need current and voltage. So current and voltage, so we go 12 times or 15 times 12, either way. 15 times 12, which means the wattage of this circuit would be 180 watts. And if you were to solve that, you would use this Ohm's law again. I is 15, 12. This would be what, 0.8 ohms? But that wasn't necessary to find the wattage. Now, let's say we're missing one of the to here to find the wattage of the power. Let's say we know the current. Let's say it's 3 amps. In our resistance, let's say 400 ohms. We want wattage. What's the wattage on this? We need current and voltage to find wattage. We have current, we don't have voltage. So in order to find the voltage, we've got to go to Ohm's law first and solve for V. So, grab the calculator. We have I and R, so I and R. So I times R. So it'd be 3 times 400. That's a 1200. It's a 1200 volt battery. Okay, now we can solve for wattage, for P. I is 3, so clear that out. 3 times voltage, which is 1200, equals 3600. So the wattage on this one would be 3,600 watts. And same applies if we didn't have amps, but we had voltage. We didn't know this one. We had these two numbers. We would go to our Ohm's law calculator first, triangle, to solve for current, amps. Once we have then we can go with these two numbers to solve for the wattage through our wattage law. So let's erase this real quick, and I will show you the actual wheel, the Ohm's law wheel. All right, so this is the Ohm's wheel. As you can see, there's a few more formulas on here. Watts, volts, amps, ohms. What you see here is a mathematical relationship between all four. With these formulas, you can solve for all four, depending if you have one or the other of the following inputs, whether it's power over inductance, which would be wattage over amperage, so on and so on. Here's your basics: Ohm's law, Watt's law. But here's the master wheel that gives you all of the formulas. But just starting out with your basics, your Ohm's law, your Watt's law, you can solve for quite a bit of the information you need to work with your equipment. So, if you want to get into this a little further, you can certainly look it up in many electronics and radio books. Well, I hope this got you going in the right direction for Ohm's law and Watt's law. appreciate you guys stopping by and checking out my videos and learning a little bit more about radio science. Not really sure what I'm going to do for my next video at this time, but anybody have any suggestions, let me know in the comments below. I kind of like darting around from different points of radio, so we'll see. Anyway, it's Alpha Delta 7 Lima November, and I'm clear. See you later.